Hi student, in this video session we are going to explain about how to find out the order of reaction by initial rate method. There are various methods are known by which we can find out the order of reaction, and out of those different methods, initial rate method is also a very important method by which we can find out the order of reaction. As we know that rate of reaction directly proportional to the concentration of reactant to the power n. So rate of reaction or proportionality constant K, reactant, let us consider reactant A to the power n, so it is n. If we consider two different concentration A1 and A2, then we have R1 equal to K concentration A1 to the power n, and R2 equal to K concentration A2 to the power n. This is the first equation, this is second and third. Dividing equation 2 by 3, it will be R1 by R2 equal to concentration of A1, concentration of A2 to the power n, or we can write like this: concentration of A1, concentration of A2 whole to the power n. Now, taking log both sides of this equation, we will have log R1 by R2 log concentration of A1 by concentration of A2 to the power whole n. Making simplification, we have log R1 minus log R2, and in this part log concentration of A1 by concentration of A2 whole to the power n. Therefore, it will be like this: log R1 minus log R2 n log concentration of A1 minus log concentration of A2. Now we can easily find out the value of n. N become log R1 minus log R2 divided by log concentration of A1 minus log concentration of A2. So this is the expression, and here n represent order of reaction. Order of reaction. By using this equation, we can find out the order of reaction, and it is the desired equation, that is equation number 4. And R1 and R2 represent rate of the reaction at two different concentration. And what we have studied about the rate of reaction, it is simply change in the concentration of the reactant and product with the change in the time t. For reactant we use negative sign, which indicates that decrease in the concentration of the reactant is taking place, whereas in case of product we use positive sign, indicate increase in the concentration of product. So this can be further written like this: dC1 by dt minus dC1 by dt. C represent the change in the concentration of the reactant, and R2 minus dC2 by dt. Now if we put the value of R1 and R2, we get another equation which is also known as differential rate method, which is used to calculate the order of reaction. I hope that these methods are very simply, all of you have understood how to find out the order of reaction. Now the third method that we are applying right now, and that is the graphical method. Graphical method by which we can easily calculate the order of reaction, or we can say that this type of graph is applicable to identify a particular type of reaction in terms of their order. For example, zero order reaction. If we plot a graph between concentration and rate, as we know that zero order reaction is completely independent upon concentration of the reactant, so its graph will be like this. This type of graph simply indicates that the order of reaction is zero order reaction. Now, first order reaction. First order reaction, if we plot a graph like this, concentration and this is rate. As we know that the rate of chemical reaction is directly proportional to the concentration of the reactant, so its graph will be starts from the origin. If you observe this type of graph with rate and concentration, then it will be the first order reaction. Similarly, second order reaction. Second order reaction. If we draw graph like this with respect to concentration and rate of reaction. Second order reaction, it will be concentration square and this type of graph. simply indicates that the nature of the reaction is second order, and so on third order. If we draw a graph like this is rate and this is concentration whole cube, and we observe this type of straight line which indicates that the reaction is of third order. If we observe this type of graph, second order. If we observe this type of graph, first order, and the last one, zero order reaction. So, by plotting a graph between concentration with respect to rate or rate with respect to concentration, if we observe this type of graph, then we can easily find out the order of reaction. Calculation of order of reaction, graphical method. And now the last method by which we can easily calculate the order of reaction, and that is hit and trial method, which is also known as integrated. Here I am writing integrated rate method. Integrated rate method. As we know that the value of K is different for different order of reaction. So in case of zero order, if we talk about zero order, then K equal to A naught minus A by T. This type of expression satisfies zero order reaction. Similarly, first order, it is K equal to 2.303 by T log A naught or A0 by A. If the given condition satisfies this expression, then the reaction will be of first order, and so on. So it is also known as heat and trial method. It is used to calculate the order of reaction, and all these methods simply indicate that order of reaction is not a theoretical value. It can be experimentally calculated by all these given methods. I hope that all of you have understood the concept behind how to find out the order of reaction. In our next session, we will talk about pseudo order reaction and some topics still remaining like molecularity that will be also discussed in our next video session. Till then, thank you and goodbye.